So, good morning students, all my dear 10th class students, welcome to our maths class. So we are continuing our trigonometry chapter, important and interesting chapter, and there are 4 exercises in this. We completed 3 exercises, lot many formulas we discussed. So in the first set, we discussed about angle and an important formula, that is Pythagoras Theorem, the relation between 3 sides of a right angle triangle. If 2 sides are given, we can find the third side. If any 2 sides are given, we can find the third side by using the Pythagoras Theorem. That is very important theorem, and in many problems we applied it. Everywhere we are applying it throughout this chapter. And next, after studying the Pythagoras theorem, I defined all the 6 trigonometric ratios. Sin theta is equal to opposite side by hypotenuse. Like that, two sides, if we take it as a ratio, there are different names. So 1, 2, 3, 3 sides of a right angle triangle. If we take 1, 2, there is one name. If we take the ratio of 3 and 2, there is one ratio. 2 and 3, one ratio. 1 and 2, one ratio. 1 and 3, one ratio. 3 and 2, one ratio. Like that, 6 trigonometric ratios we defined, and I gave all the formulas. So many times we applied those formulas in solving the problems. 6 trigonometric ratios also over. Next, after completing the first exercise, for the second exercise, I gave a table. The values of trigonometric ratios for some specific angles. That also I explained you, and even we derived it. We derived the values, and after that I prepared a table. So and asked all of you to practice those values. You have to remember the value. So for 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, for these angles, what are the values of the trigonometric ratios? That you need to remember. That also we completed second exercise. For the third exercise, I gave the formulas for on complementary angles. Sin 90 minus theta. For 90 minus, sin changes to cos, cos changes to sin. Tan changes to cot, cot changes to tan. Secant changes to cosecant, cosecant changes to secant. Those formulas also I give. Next, for the fourth exercise, so I am going to give 3 important identities. So identities, that means it is a formula. If it is true for any value of the variable, we call it as an identity. So I am giving 3 identities in this trigonometry, relation between the trigonometric ratios. So even not only giving the formula, I am going to derive it. So I am going to derive the formula. So these 3 formulas you have to remember, along with all the previously discussed formulas. Previously I gave so many formulas in this chapter, that again I will remind you, and specifically these 3 identities. So after that we start the last exercise, that is fourth exercise. So now let us write the identities. So even I am going to prove it. The first formula is sin square theta plus cos square theta is equal to 1. This is the formula. I am going to prove it, and for any value of theta, this is true. Suppose if theta is equal to 1 degree, it will be 1. Theta is equal to 2 degrees, it will be 1. Theta is equal to any angle, this will be always 1. So that means if it is true for every value, we also call it as an identity. This is the first identity between the trigonometric ratios. So sin square theta plus cos square theta is equal to 1. You have to remember this. So I am proving this. Write down. Sin square theta plus cos square theta is equal to 1. First formula. Write down. So how I am proving this? Proof. Proof for this formula. Students, whenever we have trigonometric ratios, so we take a right angle triangle. See here. ABC is a right angle triangle. This is called opposite. This is called adjacent. This is hypotenuse, provided the angle is here. If this is theta, because this is opposite to theta, it is called opposite side. This is adjacent to theta, attached to this theta. This is called adjacent side. This is the greatest side, always called hypotenuse. So this is a right angle triangle I took. Okay. Now I am going to prove this. Sin square theta plus cos square theta is equal to 1. This is the formula. We also call it as an identity. Identity means for any angle this is true. So identity means same. Left side and right side both are same. That is the identity, equal. So I am proving this. I am going to prove this identity. See here. Don't write. Let ABC be a triangle. Which triangle I am taking? I am taking ABC triangle. Angle B is equal to 90 degrees. This is, whatever I am taking, I am writing here. Let ABC be a triangle. ABC be a triangle. Angle B is equal to 90 degrees. Okay. Now, then, what is sin theta? What is sin theta from this triangle? What is sin definition? Sin theta definition is opposite by hypotenuse. What is sin theta definition? Opposite by hypotenuse. Even we can write what is the opposite side. Actually, this opposite means it doesn't look good. So we have to mention the name of the side. What is the opposite side? BC. It will be proper. BC. By hypotenuse is what? AC. See here. Don't write. Sin theta, because a problem is dealing with the sin and cos. I will write sin theta and cos theta. What is sin theta definition? Opposite by hypotenuse. BC by AC. Okay. Next, cos theta definition. What is cos theta definition? Adjacent by hypotenuse. What is adjacent side? AB. By what is hypotenuse? AC. Cos theta definition, adjacent by hypotenuse, AB by AC. We know these definitions. What we require? See, what we require? We require sin square theta plus cos square theta. This is we require. Sin square theta plus cos square theta is required. What is sin theta? Don't write. BC by AC. Sin theta is BC by AC. Cos theta is AB by AC. Sin theta value BC by AC. Cos theta value AB by AC. Take LCM. AC square LCM. What is the LCM? AC square. AC square, denominator LCM AC square. What is the numerator? BC square plus AB square. AB square plus BC square. Now, according to Pythagoras Theorem. What is the Pythagoras Theorem? Opposite side square plus side square is equal to hypotenuse square. Pythagoras Theorem. Simple Pythagoras Theorem. Side square plus side square is equal to hypotenuse square. That is the Pythagoras Theorem. Tell in terms of BC, AB and AC. What is the Pythagoras Theorem? BC square plus AB square. BC square plus AB square is equal to what? AC square. This is the Pythagoras Theorem. BC square plus AB square, opposite square plus adjacent square is equal to hypotenuse square. That is the Pythagoras Theorem. So see here, BC square plus AB square is equal to what? AC square. AC square by denominator AC square. See it carefully. How I am applying the Pythagoras Theorem. In place of BC square plus AB square, what I write? AC square. Why? Because Pythagoras Theorem. opposite square plus adjacent square is equal to hypotenuse square. So in place of BC square plus AB square, what I wrote? AC square by AC square. Same, get cancel. 1. Both get cancel 1. Therefore, sin square theta plus cos square theta is equal to what? 1. Proved. So I proved this identity. This is the first identity. This is very, very important formula we are going to use in the next exercise. And even in higher classes also, when you go to inter first year, wherever you go, so trigonometry will be continued, and we use this formula everywhere. So sin square theta plus cos square theta is equal to 1. This I proved. How? Simple. I wrote sin theta definition, opposite by hypotenuse, BC by AC. Cos theta definition, adjacent by hypotenuse, AB by AC. What I require? Sin square plus cos square I require. So sin square, that means BC by AC whole square plus cos square AB by AC whole square. What is the LCM? AC square. AC square, AC square, LCM is AC square. Numerator is BC square plus AB square. BC square plus AB square, opposite square plus adjacent square is equal to hypotenuse square AC square. This is equal to AC square by AC square. Get cancel. Answer is 1. So write down this proof. First identity, write down. Followed or not? So this can be done in 2 more ways. I will, after completing all the 3 proofs, I will give it as a formula. So first write up to here only. Write down. Followed or not? Second formula or second identity is write this formula, this identity, second identity. I am going to prove it. Write down the second identity, that is second formula or second identity. So how I am going to prove it? Same method. See here. So when I am explaining, don't write, because if you want, I will give time. Whatever time you want, you take it, because there is no syllabus tension, because comfortably we are completing the syllabus, no problem. So this chapter also we are going to complete. So no tension with the syllabus. I will give time, but when I am explaining, don't write. Just listen to me, see the steps and listen to my explanation. See here, students. Proof. Let ABC be a triangle. I am taking a triangle ABC. ABC be a triangle. Angle B is equal to, see, always we take a right angle triangle. So which angle is right angle? This is right angle. I am taking B is equal to 90 degrees. Let ABC be a triangle. Angle B is equal to 90 degrees. That triangle I am taking. What ratio we want? See here. I want secant theta because the problem is in terms of secant and tan. What is secant definition? Secant definition: hypotenuse by adjacent. Secant definition: hypotenuse by adjacent. What is the hypotenuse here? In these three sides, what is the hypotenuse? The greatest side is always hypotenuse. AC by adjacent is AB, because I am taking this angle as theta, AB. Next, tan. Tan definition. Tan definition. What is tan definition? See the tan formula. Opposite by adjacent. What is opposite side? BC by adjacent is AB. So I got secant and tan both. Secant theta is hypotenuse by adjacent, AC by AB. Tan theta is opposite by adjacent, BC by AB. Now what I require? I require secant square minus tan square. This value should be 1. Answer should be 1. So secant theta formula. Secant theta formula. See, secant theta value AC by AB. Tan theta value BC by AB. Secant theta value AC by AB whole square minus tan theta value BC by AB whole square. Square is for numerator and denominator. AC square by AB square minus BC square by AB square. AC square by AB square minus BC square by AB square. What is the LCM? AB square LCM. What is the numerator? AC square minus BC square. AC square minus BC square by AB square LCM. LCM is AB square, AC square minus BC square. AC square minus BC square. How to further simplify? From Pythagoras theorem, by Pythagoras theorem, see here. Pythagoras theorem. What is the Pythagoras theorem? Just now I applied. Many times we are applying the Pythagoras theorem. You should be perfect with that. It is not that we studied only in this chapter. Even you studied in the geometry and in lower classes, and even in 10th class also, in geometry also we are going to study, and trigonometry also many times we used it. So what is the Pythagoras theorem? Side square plus side square is equal to hypotenuse square. See here. AB square, BC square, opposite square plus adjacent square is equal to hypotenuse square. This is the Pythagoras theorem. See here. Opposite square BC square plus AB square is equal to AC square. This is the Pythagoras. But what we require? AC square minus BC square. So take BC square that side. AB square is equal to what? AC square minus BC square. See, we require AC square minus BC square. So BC square take it to the right side. Keep this same. BC square taken to the right side. What it becomes? Plus BC square will become minus BC square. So AC square minus BC square, the complete numerator is equal to AB square. Numerator is totally equal to AB square. Numerator is equal to, see, AC square minus BC square, same value is equal to what? AB square. Denominator is AB square. Cancel, answer is 1. So therefore, I proved that secant square minus tan square is equal to 1. This is the third identity I have proved. AB square cancel. Get cancel, that is 1. Students, followed or not? Write down. Student, I told you there are three identities. So second is also over. Now I am going to derive the third identity. Third identity is cosecant square theta minus cot square theta is equal to 1. This is another identity. Third identity. Cosecant square theta minus cot square theta is equal to 1 is another identity. Now I am going to prove it. Same process. See here. Let ABC be a triangle. What triangle we take? We always take a right angle triangle. Right angle means one angle should be 90 degrees. So I am taking B is equal to 90 degrees. And theta means this angle I am taking theta. That also we can mention. Let this is theta. Now, then cosecant theta definition. Cosecant theta definition. Cosecant theta definition, hypotenuse by opposite. See the formula. Cosecant theta definition, hypotenuse by opposite. Formula. What is hypotenuse? AC by hypotenuse by opposite BC over. Cosecant theta definition is hypotenuse by opposite AC by BC over. Cot theta definition. Cot theta definition is adjacent by opposite. Cot theta definition is adjacent by opposite. What is adjacent side? AB. Opposite side BC. Cosecant theta is hypotenuse by opposite AC by BC. Cot theta is adjacent by opposite AB by BC. You know these formulas. So first, starting itself, I gave the 6 trigonometric ratios. I gave the definition of sin theta, cos theta, tan theta, cosecant theta, secant theta and cot theta. All the definitions I gave, I am applying the formulas. That's all. Now, what we require? Cosecant square theta minus cot square theta. This value we want. I want this value. And I have to get the answer 1. Cosecant definition. What is cosecant definition? AC by BC. Cot definition. AB by BC. Cosecant definition AC by BC, cot definition AB by BC. Cosecant definition, cot definition. AC square by BC square. Square is for numerator and also for denominator. Minus numerator AB square, denominator BC square. Take LCM. LCM. What is the numerator? AC square minus AB square. What is AC square minus AB square? The relation between three sides of a right angle triangle is Pythagoras theorem. So by Pythagoras theorem, what is the Pythagoras theorem statement? We can write in three ways. Original statement is side square plus side square is equal to hypotenuse square. If we take this to the right side, we will get second case. Or in keeping this here and taking this to the right side, we will get the third case. Same theorem we can write in two more ways. Total three ways. Side square plus side square is equal to hypotenuse square. Or suppose if I am taking AB square right side, what it becomes? Tell. BC square is equal to what? AC square plus AB square right side minus AB square. So BC square is equal to AC square minus AB square. AC square minus AB square is equal to BC square. AC square minus AB square is equal to BC square. AC square minus AB square is BC square by BC square. Cancel, answer is 1. AC square minus AB square is equal to BC square by BC square. BC square cancel, answer is 1. So therefore, what is the value of cosecant square theta minus cot square theta? 1. Proved. 1. Write down this third identity. 3 identities are over. Students, write it neatly with all steps and draw the triangle. Write down everything. Write it neatly, maintain very good notebooks. Students, just now we derived 3 identities. No, I am writing all the identities systematically. So at a time, so that you can practice it. So same formulas I am writing once again. What is the first identity we derived? What is the first identity? Sin square theta plus cos square theta is equal to 1. This is the first identity I derived. Same formula we can write. Take cos square to the right side. What it becomes? Sin square is equal to 1 minus cos square. Same formula you have to remember like this also. Sin square is equal to 1 minus cos square. You have to remember this formula. Same way, the same can be done like this also. Another way also, cos square is equal to what? Cos square is equal to 1 minus sin square. Cos square is equal to 1 minus sin square. Three ways. Same formula in two more ways. See here, don't write. Second identity I derived is secant square theta minus tan square theta is equal to 1. I derived this formula. Secant square minus tan square is equal to 1. Same I can write in two more ways. Take plus tan minus tan square to the right side. Then secant square is equal to what? Secant square is equal to 1 minus tan square to the right side plus minus tan square right side 1 plus tan square theta. Or tan square theta is equal to secant square minus 1. Tan square is equal to secant square minus 1. So total, this formula I derived, taking minus tan square to the right side, secant square is equal to 1 plus tan square. Or plus 1 this side, secant square minus 1 is equal to tan square. Secant square minus 1 is equal to tan square. Next, third identity what I derived? Cosecant square theta minus cot square theta is equal to 1. I derived this formula, identity. I can write it in two more ways. What is cosecant square? Tell. Cosecant square is equal to 1 minus cot square that side plus cot square. 1 plus cot square. Third one. Cot square is equal to cosecant square minus 1. Cot square is equal to cosecant square minus 1. Sin square plus cos square is equal to 1. Secant square minus tan square is equal to 1. Cosecant square minus cot square is equal to 1. I derived all the three identities. These are called identities. So this can be done in two more ways. This can be done in two more ways. Taking this term, one term to the right side, one term to the right side like that. So this can be done in two more ways. These are the three identities I derived and again I wrote. So you have to remember, practice. How you remember that you decide. So you either you by heart or you practice or you write number of times, whatever you do it. Because even I derived also how these formulas came, how these identities came, I derived also. When I derived, it is easy to remember. So these three formulas, new formulas. And once again I will remind you the previous formulas also. So see here, I derived this, even third exercise, beginning I explained, even before the third exercise also 2 days back only, I explained this formula. Sin theta is equal to, sin is the reciprocal of cosec, cosec is the reciprocal of sin. This formula I explained. Sin is opposite by hypotenuse. Opposite by hypotenuse. Cosec is hypotenuse by opposite. Both are reverse, reciprocal. Sin means 1 by cosec. Cosec is 1 by sin. This already many times I explained. Next, same type of relation exists for cos and secant. Cos is equal to 1 by secant. secant is equal to 1 by cos, because both are reciprocal to each other. Cos is adjacent by hypotenuse, secant is hypotenuse by adjacent. Same relation exists for tan and cot also. Tan theta is opposite by adjacent, cot theta is adjacent by opposite. So tan is equal to 1 by cot, cot is equal to 1 by tan. This formula also we know. All these are not new. Already from the beginning it is a definition itself. These are not formulas, like it is a definition itself. So sine is equal to 1 by cosec, cosec is equal to, even third exercise before also I wrote these formulas. Once again I am writing so that all will be at a time. Next, seventh formula, if you divide sine by cos, what is the sine definition? Opposite by hypotenuse. What is cos? Cos definition? Adjacent by hypotenuse. So hypotenuse cancel, opposite by adjacent, which is nothing but tan. So sin theta by cos theta, if you write the ratios and the denominator get cancelled, so finally we will get tan theta. So tan theta is also equal to sin theta by cos theta. Suppose problem is, say in question we have tan and we have to change it into sin and cos. So in place of tan, what we can write? Sin by cos. So same way, cot theta is equal to reciprocal of this, cos by sin. Sin. These three are new formulas, just now we derived, and these are old formulas only. Once again I wrote because in the next exercise we use these formulas. So you have to practice these formulas. These are the last set of formulas. So with that we can complete this chapter. Only one exercise we have. So fourth exercise, for that these formulas are sufficient. So first I explained about the Pythagoras theorem, that is one set of formula. Second is I derived all the 6 trigonometric ratios, sine, cos, I defined all the 6 trigonometric ratios, sine, cos, tan, secant, cosecant, cot. Third is I wrote a table, the values of trigonometric ratios for some specific angles, 0 degrees, 30 degrees, 45, 60, 90. Fourth is for complementary angles, sin 90 minus theta, cos 90 minus theta, sin theta, secant 90 minus theta, cosecant 90 minus theta, secant, tan 90 minus theta, cot 90 minus theta is tan. Like that I derived that set of formulas. Today 3 more formulas, identities, that also I derived. These are the general formulas. From the definition only these formulas will come. So all set of formulas I explained. Write these formulas very neatly, big letters, so that you are able to see every time whenever you open your notebook, these should be visible, because if you see more number of times, then you can remember in your mind. Whenever you are solving the problems, quickly you have to use which formula is required there. So practice these formulas and these 3 identities, these already discussed formulas, even third exercise before also I told this. These formulas, this 8, not only 8, see this is 3 ways we can write. This we can write in 2 more ways. This we can write, original formula is this, it can be written in 2 more ways. Suppose cosecant square minus 1 is there, in place of it we have to write cot square. Suppose 1 plus cot square is there, in place of it we can write cosecant square. I thought you should know all the formulas. Students, you practice these formulas. Be careful with cos and cot. If it is not visible, I will write big. This is cot, this is cos. Don't confuse. Cot, C-O-T. Cos, C-O-S. Cot, C-O-T. Cosecant, C-O-S-C-C. Like that. Write very neatly and practice it. So tomorrow we will start the 4th exercise. 4th exercise we will start tomorrow. So but before you attend the tomorrow's class, practice these formulas. Otherwise, the next exercise is difficult exercise. Problems are big problems, and even essay questions are there. Very important questions for this public exam, and even for your inter first year also, these type of simplifications are very, very important. So a lot of simplification, lot of analysis, so lot of formulas you need to apply. So tomorrow when you are attending this class, at the same time practice all the formulas from the beginning, from the first day of this topic. So this is, I think, 12th class in trigonometry. So in these 12 classes, whatever formulas I explained, you practice all, and don't fear, no more formulas are there. So I am not going to give any extra formulas in this chapter. All the formulas are over. So this topic is going to be completed. We are in the last exercise. Tomorrow we will start, but practice the formulas. Okay students, let us conclude here. Thank you very much, and tell your friends also that we are going to start the 4th